Knowing how to build and configure a Kubernetes cluster is very important when going to the exam. In this video, we're going to build a 3-node Kubernetes cluster using kubeadm. Now, before we get into this video, please like this video and subscribe to my channel. To perform this installation, we will make use of the Kubernetes documentation. Here I have my documentation page open. Let's search for install kubeadm. Let's click on the first link. Now let's take a look at the prerequisites. Will it have machines running one of the following operating systems? Let's see what I have got. Here I have Ubuntu 18.04 running, and I have 3 EC2 instances running Ubuntu OS on AWS. Make sure you have the required ports open, and this is where a lot of people face issue when trying to establish the connection between master and worker nodes. If you are asked to create a cluster in the Kubernetes exam, you don't have to worry about opening the ports. In this case, I have opened the ports for my nodes already. Let's scroll down. Next, we have to let iptables-c bridge traffic, otherwise we run into connectivity issues. We can do this by running this command on all our 3 instances. We see no output. So we need to enable this by running sudo modprobe br_netfilter. Also, let's do this on all 3 missions. Now let's verify this by running this command again. We see there's the output. Next, we run these commands to create new kernel parameters. And also, this should be run on all the nodes. Let's scroll down. Next, we install the container runtime. In this tutorial, we will be using Docker as our container runtime. Click on this link for instructions. Let's click on Docker. We first install the packages. They should be run on all the nodes. This may take a while. The next step, we will add the Docker's official DPD key. Copy this. And this on all 3 nodes. Next, we add Docker app repository. Next, we install the Docker container runtime. Again, run this on all 3 machines. And this may take a while. Next step is to set up Docker daemon, and this command creates a daemon.json file. Run this on 3 nodes as well. The next command creates a directory for Docker service. Next, we run system control daemon reload and restart Docker command. to start the Docker service. We can verify the Docker is running and active by running sudo systemctl status docker.service. We see it's active. Let's run this command on all three machines and verify. Active and running. Active and running. Now let's go to the previous page and install Kubernetes packages. We will install these three packages on all our machines. To boost up the cluster, we use kubeadm. Kubelet runs on all our machines and manages pods and containers. And kubectl is the command line utility we use to interact with the cluster. And here we have instructions for different types of OSs. Let's run these commands which will update the repository and install the packages. And this should be run on all the nodes. While this is running, let's go back to the documentation. The next section, configuring the secret driver, is not applicable when we are using Docker Container Runtime. When using Docker Container Runtime, kubeadm will automatically detect secret driver for the kubelet. If you are not using Docker, we follow these steps to specify the secret driver. Next, to create a cluster, we click on this link. Scroll down to initializing the control plane node. The first step is not applicable as we are not going to deploy a highly available cluster with multiple control plane nodes. In this tutorial, we are going to have one control plane node and two worker nodes, so we will skip this step. The second step is to choose a network add-on. There are a number of popular pod network add-ons available, such as Vue, Cilium, Calico. In this tutorial, we will be using Vue as our pod network add-on. And step 3 is ignored as we are using the Docker Container Runtime. In the fourth step, we specify the Kubernetes API server's IP address. The API server listens on the specified IP address on the master node, so the API server is accessible by worker nodes and other clients. Next, we initialize the control plane node by running kubeadm init command followed by the arguments. Let's go to our master node. Now, before we run this command, let's check the IP address of my node. It's 10.0.1. We need to run this command as root user. And then the arguments. Let's copy this and paste it. The network CIDR we use for pod network should be different from the CIDR of the nodes network. Here I'm going to use 10.244.0.0/16 CIDR block. The next argument will be the API server's advertiser address. And here I type the private IP address of my master node and hit enter. This is performing few pre-flag checks and this may take a while. Now you see the control plane has initialized and says we need to run these commands as regular user. First command is creating a .cube directory in the home directory, and the second command is copying admin.conf file into the .cube directory. Third command is changing the ownership of the file. This file contains information about the cluster. Let's run these commands. Now let's install a pod network. In this tutorial, we will be using Vue. We can follow this link. We can see the other options available. We have Calico, Kernel, Cilium, all these options are available for us to use. As I said, I'll be using Weave for this tutorial. Let's search for weave.works, and this is where you can find the command to install Weave in the documentation, and click on this link, creating highly available clusters with Kuberium. As you can see here, we already can find the command to install Weave. Let's click on this link and scroll down until we find the command to install Weave. Let's copy this and paste it here. This creates the core network components, and this command is used to join worker nodes to our cluster. Let's get the nodes in our cluster. As you can see, we only see the control plane node. To add worker nodes to our cluster, we copy these commands and run on both our worker nodes. And also, this command should be run as a root user. A clear screen for better visibility. The output says the node has joined the cluster. Same for our worker node 1. Let's go to the master node and verify this. Clear screen. As you can see, now we have a 3-node cluster with 1 master node and 2 worker nodes. The status says it's ready. The version we are using is 1.20.1. Let's verify our cluster is working by running a pod. Let's run a BusyBox pod. Let me go to the cheat sheet. Let's search for BusyBox. You can also do this by running a Kubernetes run command. I'm just lazy to do that. Let's copy this. Keep city pods dash -OY. As you can see, this pod is running on my worker node 2. And yeah, that's it for this video. If you found this video helpful, please like this video and subscribe for more content. Thanks for watching.